Okay, this is going to be part one of the build on the new version of the Foki robot. Past history on this, basically back in the 1960s in Argentina there was a company called Daisa, D-A-I-S-A, Daisa, I don't know. Anyway, they made a robot question and answer board game, and just like, as you can find on my channel, many of the question and answer games that are robot based, in this case it had two lights in the eyes that would light up when you got the answer correct. And basically the robot didn't move, it just held two batteries, had the two lights, and then two wires would come off each of the two arms. And if you touch the two wires together, that would simply make the lights light up. So you'd take the two wires and you'd touch them down on the board in different places. One for your question, one for the correct answer, and if you were right, then the eyes lit up. The design of it, though, was something that was desirable for collectors, so they started wanting to get hold of just the robot. And so then I started making in tin, even modified original ones, then 3D printed versions of it that could walk. And 7 years ago I put up a video and STL file so you could print one that would walk. And then the only problem with that was it was based on a gear motor, which is very hard to find these days. In fact, I only know of one place where you can buy it, and they only have a few of them left. So I decided I'd go ahead and redesign it with a motor that's more in favor right now, which is the N20 style, and you can get them dual shaft drives and all kinds of different gear ratios. So I went with that. Added moving arms when they walked. Still have the lit eyes. Now it runs on two AAA batteries. The original one I ran on a single AA battery, and then had to use a power boost circuit from a yard nightlight to light up the LEDs. But now that we have 3 volts with the two AAAs, we don't have to do any of that. And oh, and in the original one, the ear parts I printed as just a flat disc. Then I heated them and I thermoformed them between some silicon impressions that I made off the actual toy, but that didn't make it easy for any of you that wanted to make one, because you wouldn't have the silicon mold, the impressions. So on the new one I went ahead and made the file so it simply just prints the ears so you can print them. The original one had a metal piece of diamond grate for the eyes. Again, you may not have a source to be able to come with it, so now this one has a 3D printed diamond grate for the eyes. In other words, everything on here can be 3D printed. The only thing that's not is the motor, the battery box, a couple of screws, the LEDs, the on-off switch. So other than that, it's 3D printable. So we'll do this build in a couple of steps, because there are certain parts that I glue and really need to dry before I proceed. And since I don't edit the videos, then it makes more sense to just split it up. Now this is one of the arms. I actually print the arms on my printer this way. Go ahead and have them add the little pad for stability, but then you don't have to use any supports when you print this part. And the arms were white on the original toy, and the claw parts were metal. Nothing special metal. So I just printed these in some silver PLA, and these will just get glued onto the end of the arm, so they look like that. And that way you don't have to do any painting. I'm going to go ahead and use the weld-on number 16, which is what I always use for gluing PLA, because it actually melts the PLA parts together. The glue bond from this is stronger than the 3D printed part. You can go ahead and use your super glues and your CA glues and stuff, but they're just a surface glue, and that's why eventually all CA glue parts will fall apart. It's just a matter of years, usually, how many years you'll get away with, because as temperature changes and parts expand and contract and expand and contract over seasons, over years. Since it's just a surface glue with CA, they get little fractures and cracks, and the glue eventually is going to let loose, and that'll be the end of that. So I always prefer to use a glue that actually melts the two together. Put a little on there. put that right on there. Like so. It sets up pretty quickly. Got to set this someplace while I glue up the other one. Prop it in that door there. These are a couple of the parts that I want to have set up. Now these, since these do dry fast, these aren't the ones that are really holding up the build. The ones that take longer are going to be like the battery box, because it's a dissimilar type plastic. Trying to get this centered about right. I think I got her eyeballed okay. About like that. Let's let that set up as well. Okay. Yeah. So on the shoulder part, here's where the battery box is going to get glued into that insert, and you can see there's a divot down in there where the wires can go on the back side of the battery box, so when this goes all the way in, it can sit flat. You just bend them back, sits in there, and this is where you're going to glue the part. Now it is easier, since the arms move, you have these inside parts that will drop down in here. It is easier to do this part before the battery box is in, to attach them to the arms. You can get them in there afterwards, it just takes a little bit more fussing. And so why not show the right way? I'm just going to grab one of these arms. And you'll simply have to find some sort of screw. I'll show you on the other one. I know it's off camera. Basically, trying to screw through this paddle part, which is what's going to get pushed to make the arms move. Screw through right into the arm, and that way, if you don't tighten the screw up all the way, you can position the arms without breaking anything. You can keep it where it's adjustable. Okay. Sort of, kind of. You can use any kind of screw you want, an old wood screw or whatever you got laying around. But in the end, you just want to make sure that the arm can in fact move freely. You've got these little paddle things. Now let's do the other arm. You know, if they don't move freely, then go in and clean that circle out with an X-Acto knife or something until the parts can move freely. Because if it's binding up, you're going to have a problem. Like that. Screwdriver doesn't really fit these screws that I'm using. Actually, I need a bigger Phillips to line up with these. There we go. Alright, so now we can actually glue in the battery box. Let me show you just it's a AAA battery, 2-cell. The wires come down, just fold them back so they'll be out of the way. I'm going to use some of the E6000. I'm guessing that probably hot melt glue would probably work just as well. I don't use hot melt glue, but I'm just saying it'd probably be quicker, and it's just holding a battery box in, so it's not like it's super critical. Not like you couldn't fix it if it came loose. So then I'm just going to poke those wires in through there like that. Push this down in there. And looks like I'm trying to get some glue oozing out where I don't want it to ooze out. Getting it on my arm part where I didn't want it. But so basically this is the assembly that I just need to set aside and let that battery box completely glue into place. So just got to find a place to put this. Where can I set it? Hang on. Just trying to find a good place to put it where it won't fall or anything like that. Alright. So, what part should we do next? Well, next, let's work on the feet. Let's talk about the feet. Before we actually do anything. So back 6-7 years ago, the original one, the feet stayed stationary. They were just glued. Everything was solid. And when the robot walks, as you know, there's a pin that comes down and will tip it and then drag it, set it down, then the other one tips and drags. There can be a lot of friction between this sharp edge or this sharp edge when it's being tipped, depending on the surface that you're trying to walk on. And in case you're not familiar with what we're talking about, let's take a look. You can see the little pin right there. See how it comes down and then pushes back? Well, since it's just that little teeny nubbin, if it can't provide more friction than the amount of drag and friction that the other side of the foot provides, then it's not going to propel it forward. What it's going to end up doing is just tipping back and forth and not moving at all. In order to move, it actually has to be able to pivot on the one foot that stays on the edge. Now, typically when I do these pin walkers, I like to make their feet adjustable for stability reasons. But in this case, if I do that, all I've done is I've increased the friction from being on just one edge to being on the entire foot. So this one, even though it's more stable, doesn't walk. It, in fact, does just go back and forth. This one, of course, did walk because it was the original design, but not as good on all surfaces as I would want it. So in order to improve that, I thought about it and I decided, well, why don't I just make the outside edge, and this might be kind of hard to see on this because of the color, but you can see this goes in, and I just left the corner nubbins there for stability. So when it tips, the only friction points are here and here. No friction all along here. And that would allow this foot to pivot, which it has to do as the whole robot walks. So while these two were on the machine printing, I thought to myself, you know, that's a good idea, but why don't I just take it a step further and actually put little roller wheels right in there instead of those solid nubbins. And the wheels don't normally touch except for when the foot is tipped. And now this foot can easily pivot. Makes the robot walk very well. So this prints as one piece, as you can imagine. And then I print these little teeny roller wheels with a hole in them. And then I take a paper clip and just cut some little axles. I'm probably going to drop these before we're done here. But basically, just going to hold one of the feet wheels into the foot, push in the axle, like so. There. But we don't want that axle to fall out, so I'm just going to take a little bit of glue, and you could use CA glue, you could use goop, you can use whatever you want. I'm going to use a little bit of goop because I don't have any thick CA glue right now. You could even use a paper clip to apply this, but basically you're just going to make a little cap right there. And that should fix it so that that little piece of paper clip axle can't fall out. And I'm going to do exactly the same thing for the rear. There we go. Got it in there. Don't know if I have enough glue left on here or not to form a plug. Maybe. I think so. Alright. I'm going to grab the main body. So the new body is a little bit different than the old one. I had to add certain features so I could run rods for the arm movement and fit everything on. But basically what we want to do now is we want to glue our two foot leg assemblies in. And basically, as you can see, there are slots and there are holes, and it's just going to fit like that. So I'm going to go ahead and put the old weld on number 16 on the very top of the foot here. Just make sure that you get the correct foot. You know, you want this slope facing towards the outside, and of course the biggest part of the foot facing forward. And I'm going to do that to both feet. See, the nice thing about printing these parts in colored PLA rather than painting is if you paint, the paint can make it hard to glue things together later, because the paint might release, causing a failure, like so. So we'll let that part dry up, glue up. Let's grab the next part. Let's grab the head and the part that can now be 3D printed, so you don't have to try to find a piece of metal mesh to do that. And it glues on to the inside, and I'm not sure of the best way to do this. So you can see this is going to fit in like so. It's going to fit kind of tight. I'm thinking I'm just going to put some glue top and bottom and see if I can't get it in there now. Do I want to use the fast setting stuff that's kind of runny, or I think I better go with the E6000, even though it takes longer to dry, but that's going to give me more time to position this to make sure I get it in the right place. So I'm going to put a little bit of this on the top and put a little bit of this on the bottom. So you're thinking, doesn't this guy know how to build this? Well, I've only put together the one prototype that you see sitting there, and that was actually over a month ago, because I've been waiting for motors and battery boxes and stuff like that. So, trying to remember. Okay. That worked out pretty good. As you can see it sitting in there. but it will need to set up a little. But I think we can progress on here. Let's grab this. Okay, got some more parts. Here's one of the 3D printed ears. Prints the shape. I saved the support, so when I print it prints flat, sort of like this, so all the support goes on the back side, and then you just peel it off the support, since the back side can't be seen on the ears. Now the next part we're going to put in, I print it in black. This fits inside the head and it holds the two LEDs. So again, in this case, you can use any 5mm LED or whatever you want. These were ones that I had left over from dollar store solar yard lights again, but I liked the color that they produced, so I just glued them in with a current limiting resistor, whatever you want. I'm using 150 ohm on the 3 volt. The two LEDs are wired in parallel with each other, and just leave these wires dangling out. Now there are a couple of small holes, and those are going to line up with the ear holes in the head. The original idea was slide it in, and when you screwed the ears in, it would hold this thing in place. But I think it's a better idea to actually apply a little bit of glue to this. And I think, pretty sure that's the way it's going to go in there. Let's just fit it. Let's fit it in there and see if things start to line up or not. Yeah, it's about the time that it's flush here on the bottom, it was starting to line up there. I'm going to try a screw in that hole without the ear on, just to make sure I've got things lining up. Yeah, I think so. So that means this side should line up too. Although I didn't clear the hole out first. See, there's a little something blocking it. So let's I may have to take it apart and clear that hole out. Let's try this, just poking this pointy thing in there first. Now let's see if the screw fits. And I'll go up a little bit more. Yeah, I think so. So the idea was that the screw could hold in that light board and hold on an ear. But again, I'm going to apply a little bit of glue on the back side of the ear and then put the screw in. Like so. And up the screw through the hole in the ear. Maybe. There we go. Put that on the head. And just snug that up. That way you can sit and position the ear how you want it, and that's how I want it. Let's just do the other ear. And let's get a little bit of E6000 on the back of the ear. These are just little number 2 self-tapping screws. Nothing special. You can buy them on eBay, you can buy them on Amazon. There we go. Alright. So, once again, we've got a part that we can set aside and let dry. I'm probably going to lay it this way to dry, just to make sure that that diamond piece that we put in there stays in place while that glue dries. Okay. I'm grabbing some parts here. So here's the N20 motor. It's a 30 RPM at 3 volt. The cams have already pushed onto the shaft. They have flats so you can't put them on the wrong way. I've already soldered some wires to the motor. The motor does have a little plus and a minus, and in this case I went ahead and put the red wire to the plus and the black to the minus. We do have to get it running the right direction when we go to assemble this thing. Otherwise your robot will walk backwards. You can see the two slots down there that the leg linkages will go in all the way down, and then the motor itself pushes into that provided area all the way down. And if I remember right, the only part that gets kind of tricky is holding all of the parts. Here's one of the leg linkage parts. They're identical, so you just put one on each side. And then these are the arm linkage parts for moving the arm. Now the only thing about them, should have cleaned that off. There we go. The only thing about them is you need to make sure you put the crook parts aiming outward, and trying to slide all of this down in there. You may have to deal with it a couple of times. I probably will have to. There's no way I'm going to hold the camera in the right angle and do this, so I'll start things and then try to give you a camera point of view without losing everything. So you can see I've got the leg ones going down on the legs, the arm ones are just sticking up here. The motor that I've just started but haven't pushed all the way down in yet. But that's what I'm going to do next. Just keep pushing it down, and then even get something to push on the top of it with until it bottoms out. I think I got it down there. We'll find out. And in fact, I guess this could be a good time just to see if everything is working right. Just grabbing a battery pack I leave laying around in the wires. Okay. It's running, it's not binding. That was what I wanted to know. We then have this black part which prints this way, no supports required. This is going to go in this way. These little slots are for those arm linkages, so these will go towards the front if I remember right. Pretty sure I remember it. Like I say, it's been a month. I might not be remembering right. The motor wires poke up through this hole. And so I'm unraveling my motor wires here. There we go. Just like that. Trying to get the arm linkage parts where they belong. This is all going to become clear here in a second. Alright, so you can see what I've done here. This is the front. So I've got those two slots favoring the front, the two arm linkage parts there. Then this should just continue to push down. And then there's a place where you could put in screws. And it's handy to use screws if you've got them, so that you can take the whole thing apart in case you did something wrong. But having said that, there's no reason that you couldn't just glue that piece in there. You know, as long as you tested it like we just did a moment ago. I'm going to screw this together because who knows, maybe this video will fail or something and I may have to shoot this video again, which means I'll need to take it apart. I think I've got the wrong two screws. Yeah, that's not a self-tapping screw. That's one of the screws for the on-off switch. Let's see, what this one felt like the right kind though. I believe those are the on-off switch screws. Yep. These self-tapping screws are going to be pointy on the end. So now we got the right screws. So now let's throw some battery power on again and just see if the motor's able to run or if things are jamming up. If we've got things jamming up, then we'll take it apart and figure out what's going on. Okay, it's a good sign. Nothing's jamming up. Trying to think how much further we can go without the other parts being dried. I think we can go one step further here. There's now this piece, which prints flat and no supports. And the purpose of this piece is when you put this toy together and take it apart to get to the batteries, these wires could end up getting over into the arm linkage and the upper shoulder part that we have drying already, get up in there and booger things up. If we glue this piece down on top, once the body cradles everything, this provides a shield that keeps those wires from being able to get into where the arm mechanisms are. So this is basically just a way to keep the wires out of the mechanics. And we're gonna, if I remember right, there's no front or back to it, but we're just going to glue it down in there like that. See how the arm mechanics then are all over to the side, and this valley here is going to be a place where the wires can go, where they won't bugger anything up. In this case, I think I'll go ahead and use the weld-on number 16 because the fast set's fine. And it looks like I've got it centered up pretty good. So like so. So I think that's going to about do it for this part one. In part two won't be as long because it won't be as much explaining, but basically we'll be taking the shoulder part that the battery holder is gluing into. I have to have that set up, and the head part. And we'll do a little bit of soldering because we'll have two motor wires, we'll have two battery wires. Of going up to the switch, the LEDs going to the switch. Basically, it's just going to be a real simple little assembly video. Won't be much to part 2. But this is about as far as we're going to go with part 1. See you in part 2.